I'm Anil Kumar, sharing with you a word problem from the chapter of functions. The question here is, a farmer has 600 meters of fencing to enclose a rectangular area and divide it into 3 sections. Write an equation to express total area as a function of the width. Part B is, determine domain and range of this function, and part C is, what dimensions will give maximum area. So let's begin by sketching a rectangle and dividing it into 3 parts, right? So those 3 parts may or may not be equal. So 3 parts you could draw like this, right? So this rectangle has these 3 parts. Now let us say that the length is L, so both sides are length L, and these are the widths of our rectangle of the fencing, right? So fencing has a length of 600 meters. That means 600 meters is equals to 2 times length, right, plus 4 times W. Now this relation helps us to write length in terms of width. We can divide by 2, so we get 300 equals to length plus 2W, or rearranging we get 300 minus 2W equals to length. So we'll call this as the first relation. Writing length in terms of width. The question is, write an equation to express total area as a function of width, and that is the reason why we wrote length as a function of width. Now what is area? Area of the rectangle, let's say, is A, is equals to length times width. So we can write area as equals to, instead of length, I will write 300 minus 2W. And then we have width W, correct, times width. So what we get here is area in terms of width. Since there is only one variable, I can write A of W equals to all this, right, which is you can write minus 2W square plus 300W, right? So that becomes the equation to express area as a function of width. So that is our part A. You get an idea? So this is part A. Now part B is, determine domain and range of the function. Now how to find domain and range of this function? So let's do it on the right side. Now the function here is area minus 2W square plus 300W. Now area should be positive, right? It cannot be negative. And what we also see is area could be written in this factored form. So now I will actually write it in the factored simplified form. So I will write this expression as AW equals to, let me factor 2 also out. So we say 2W times, when I divide by 2, I get 150 minus W. Is it okay? So that is the same equation. We could factor 2W here, either minus 2W also. So we get 150 minus W, right? So from here we will find domain and range. So what we have here is area as a function of width equals to twice width 150 minus W. Now clearly width has to be positive, right? So this 150 minus W should be greater than equal to 0. Solving this inequality, we get 150 is greater than equals to W, right? So that becomes the values for W, and so we get domain. So in our case, domain will be W belongs to real numbers, where it is from 0 to 150, right? 150. So that is the maximum value it can have. So W you could write as between, we can write this also as interval notation, 0 to 150, right? So that becomes the domain for our function. Now how to find range for this area, right? So to find range, what we can do is we can do completing the squares method, write it in vertex form, and we know since it is minus 2w square, it is a parabola opening downwards, so we do have a maximum. The other option is we can find x-intercepts, right? And then center, the axis will have the vertex, correct? So let me try to show you on a sketch here. So let us say we want to sketch area as a function of width. So approximately it has 0 for 0, so it will be kind of like this. So the zeros for this will be at 0 and at 150. Is it okay? Therefore, the axis will be at the center, which is 75, right? So we'll find the maximum with the help of the axis of symmetry, right? So what we notice here is that the function AW equals to 2W times 150 minus W has x-intercepts at x equals to 0 and x equals to 150, and therefore axis of symmetry is at x equals to 0 plus 150 divided by 2, and that is 75 as shown here. So at 75 we'll have maximum. So let's find area for W equals to 75, which is going to be 2 times 75. So we'll substitute 75 in our original equation. So it is 2 times 75 times 150 minus 75, right? So let's use the calculator to find the answer. So it is 2 times 75 within bracket 150 minus 75 bracket close equals to. So the area is 11,250. Correct? So that is the maximum area, and that gives you the range. And from here we can say range is that the area belongs to real numbers and it is between 0 and 11, 1250, 250. So that becomes the range. It is from 0 to 11,250. The units are meters square. Okay. Now the question is, what dimensions will give maximum area? So part C, we can write down answer for part C. As we can see, width should be 75, right? So width is 75. Now for a width of 75, what should be length? That is what we have to write, right? So for a width of 75, length will be equals to 300 minus 2 times 75, which is 150 meters. And therefore, part C answer is, let me push this page a bit to the right, that the width is equals to 75 meters and length is equals to 150 meters. So that becomes the dimensions for the given function. So let me write down all the answers once again. Write an equation. So the equation here is AW equals to, so you could write any of these equations. We could write minus 2W squared plus 300W. Domain and range. Domain is from, let's say domain is from 0 to 150. The range, let me say range area, let me say y in this case, is from 0 to 11,250, and the dimensions are 150 meters by 75 meters. So these are the answers for the given question, and I hope you understand and appreciate the method of doing it. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.